Hello, it's Anna Hill here with the Farming Today podcast. The rise in global chicken production is changing the traits of the food poisoning bacterium Campylobacter, which could lead to more antibiotic resistance in humans.
We should certainly be concerned about the trajectory that we're going in here, where we get ever more chickens and therefore we get much more rapid adaptation of the Campylobacter in the chickens.
We'll have more on that a little later. First today, an anniversary. 50 years ago, a couple of scientists began trapping and testing badgers in Gloucestershire to find out as much as they could about a disease called Bovine TB. Well, as we know now, it's a very infectious disease leading to the slaughter of tens of thousands of cattle every year. What they started under what was then the Ministry of Agriculture, Fisheries and Food, or MAF, is now the National Wildlife Management Centre, bringing together scientists, vets, ecologists and pathologists with possibly the longest continuous monitoring of a wildlife population and an infectious disease in the world. Sally Challoner went along to see where it all began, Woodchester Park in the Cotswolds, to meet two scientists carrying on that work, speaking first to ecologist James Stranks.
So we entered here on the west.
Just got a little map out.
Yeah, and you can see on this map all of these different squares with the different names on them. Those are different badger sets that we have in the park.
How many have you got?
I couldn't tell you off the top of my head, to be perfectly frank. And then they're not all active at the same time because the badgers move around. Sometimes they'll use one for a season or two, then it'll be abandoned for a few years, and they move back in. So we're going to go and look at this one here, Old Oak. So now we're on top of the badger set, and we're looking at one of their main entrances down into the burrow. There's another main entrance just over there by that oak tree.
What have we got here? Your tracking equipment?
Yeah, so this is sort of like a television antenna or a radio antenna, because you fold it out like this. So we use this to track our badgers during the daytime with radio frequencies, and this is a radio tracker. The collars that we put on the badgers are quite advanced. They also, as well as using this radio tracking, it also gives us proximity sensors. So if two badgers wearing a collar come into contact with each other, or we can work that out. It also gives us very detailed GPS data and activity data, so we can work out exactly how they're moving in the landscape, who they're interacting with, and you can start to build up a picture of their social life. And then what we do with the radio is we come out, and this is to kind of confirm where they're sleeping, really, because this is quite important for badgers, because they tend to mostly stay in their social group and their sets, but we do also know that they will sneak out and they'll go and stay the night at neighbours or at rivals, sometimes for sneaky mating opportunities, sometimes for food. And this could be quite important for disease implications too, right? If they're moving to a different group, and then you have the potential for disease transmission that way.
And how many have you got with collars on?
At the moment we have 17 badgers with collars, all adults. Yeah, hopefully we'll get some more out of the rest of this year too.
So you're going to switch your device on?
Yes,
see where they are?
Indeed. Turn it down a little bit.
Anything?
Nothing this time, unfortunately.
What does that mean? He's not here?
It means he's not here. It means he's probably at one of the outlier sets, or he could be over at the neighbouring set. We have tracked him to Honeywell. So yeah, unfortunately we don't have him now, but we can check for this badger too, 10Q. He might be here.
10Q, come on.
Let's hope so.
So change frequency.
No.
Never work with children and animals.
No, exactly.
We're also joined by Claire Benton. What's your role here?
So I worked here, did my PhD here, looking at the way the badger social structure and family structure affects TB transmission dynamics. I now work on badger vaccination. But James mentioned often the badgers don't stay in their own group, and that's where things like badger hair can be really helpful.
Oh, you've got a little pot
We've got
there.
a little pot of badger hair. So what we can do is we can turn that into a badger family tree. So it's about using all the evidence together, using the trapping data, the radio tracking and the genetics, all are giving us a slightly different picture, and that affects how TB is transmitted in the population as well. So.
Now we're celebrating the 50 years of the National Wildlife Management Centre, aren't we? And it started here, didn't it, with a badger. 50 years on, we've still got TB.
Yes.
Are you disappointed that it's not moved faster, further?
I think What we have here at Woodchester has consistently played a really important role in giving that long-term picture, that evidence that we need to shape policy, to shape decision making. So there's so much work that's happened here that has moved us forward. For example, we put collars on the cattle in Woodchester Park and the badgers, and that really helped us understand about transmission risks and showing that most of that transmission risk is at pasture. It's indirect rather than nose to nose. All the field craft that we used for badger vaccination, for example, you can see we've got a trap over there. The field craft to do badger vaccination was only possible because of all the work here. So yes, it's a long-term problem, but you need that long-term science to provide the evidence alongside it.
Claire Benton ending that report. All this week we're celebrating Farmwatch across the BBC, where our BBC local radio stations in England are highlighting some of the amazing rural stories in their communities. Lush Greens is a community market garden situated in Bristol and surrounded by houses that each week provides 60 families with fresh food grown on the 2-acre site as part of a community-supported agricultural scheme. The team includes urban farmers Jimmy Thompson and Ollie Jameson and a group of volunteers who all help seed, harvest and bag the fresh veg.
Today we've got some crates of chard here, some red chard, yellow chard, white chard. We've got some garlic that's been drying for a while here in the shed now. Lush Greens is a community market garden and we grow veg with and for our local community. We grow it from seed to harvest and then that veg goes to people in the local area, many of whom are facing food insecurity. So we run a pay what you can afford veg box scheme. People sign up and become a member and then they receive a harvest of veg throughout the season. People pay what they can, so there's some suggested prices, but people can pay literally anything from £1 up to £25 per week. If they're like very, very ripe, they go in this side. You see the colour of them and how soft they are. Feel that one. Perfect.
As we would say in Bristol, Gert Lush.
It feels nice to just be part of something bigger, I guess, that's feeding people who maybe can't afford to buy their food. And I think it's a human right for everyone to have affordable food to eat, and obviously some people are really struggling at the moment, so it feels really nice to be able to help people have access to healthy food.
I think anything that can help people afford food is crucial. You know, there's an equality about it. It means people can have fruit and veg that they wouldn't normally have.
Some people live in areas that haven't got access to a big supermarket, so they might have to use their local stores, and they may not have access to fresh fruit and veg. So I think it's really, really important.
This is our main salad block. It's one of our staples. It goes out to the food banks, the food clubs, caterers, and to our veg box scheme. So yeah, this is the mainstay of Lush Greens.
The majority of our members collect from the farm. They'll turn up on bike, on foot, and pick up the veg, and then they're eating it that same day. And it just makes sense, you know, the freshness, the quality of the food that comes from growing it, picking it, eating it that same day is just second to none.
These are our summer beans. We've got runner beans with the beautiful red flowers, and then behind them there we've got the French beans. And we get amazing feedback from the beneficiaries, the members of food clubs, because they do get a lot of heavily processed, packaged and high calorie food. Obviously great when you're hungry, but they don't get as much access to that fresh stuff. If it's grown locally, you're going to get it quicker after it's come out of the ground. The flavour is just completely different when it's eaten fresh. I don't really think there's a future for agriculture that doesn't involve more community growing and more people who are eating the food being involved in the growing of the food.
Here's a bag of veg, so yeah, beetroot, chard, collard greens, salad, and then a punnet of plums.
Oh, lovely, thank you.
Cheers.
They have a really great system where they explain that you contribute what you can afford and what that contribution will mean to the community and mean to Lush Greens as well, so you make the best decision you can for your circumstances.
That was Lush Greens. Well, for more farm to fork stories all this week, you can search for Farmwatch on BBC Sounds, or if you're in England, listen to your BBC local radio station. A long-running study into Campylobacter, which causes food poisoning, shows that intensive chicken production across the globe has allowed the bacterium to spread, mix and acquire new traits, which could lead to increasing resistance to antibiotics. Scientists at the INEOS Oxford Institute looked at data from 1979 to 2024. Their research showed that since the 1960s, global chicken numbers have increased sevenfold to approximately 31 billion birds. Well, while the increase has allowed for the production of affordable animal protein, the paper says it's also allowed bacteria strains that once circulated in wild birds to mix extensively in commercial poultry populations. Sam Shepherd, Professor of Microbial Genomics and Evolution at Oxford University, who led the research, told me how the Campylobacter bacterium is evolving.
The Campylobacter that we find in the gut of the chicken host, which ultimately are the strains that then go on to infect humans, what we find is that the number of different genotypes, the number of different strains, increases dramatically with the increase in the number of chickens on Earth. So this means that as poultry production intensifies and agricultural livestock production intensifies, the chickens get colonised with many more strains, and therefore they shed many more strains into the environment. The second really important finding is that when you have lots of these strains all found together, which is what's happening in these intensive poultry systems, they evolve together and they acquire genes from one another. And the action of evolution makes them adapt more rapidly to this kind of optimum strain that's really good at colonising chickens, but also that's really good at spreading through the food production chain to infect humans.
It sounds a little bit scary. Should we be worried about the fact that actually the chicken production itself has engendered a sort of super version of Campylobacter?
It's certainly something that we should think about. I mean, there are relatively straightforward ways of making sure that we reduce the risk of infection, okay, as a consumer of chicken. So we can wash our hands carefully, make sure that we clean surfaces that have come into contact with chicken, of course, and of course cooking the chicken. But, I mean, it remains the case that a lot of the poultry that we find on the shelves in supermarkets has Campylobacter on it, and that ends up in the kitchen. So we should certainly be concerned about the trajectory that we're going in here, where we get ever more chickens, and therefore we get much more rapid adaptation of the Campylobacter in the chickens. There's another very important trait, though, that I'm sure many people have heard about, and that is the trait that allows them to resist antibiotics. Now, in the UK, we don't use antibiotics as growth promoters on farms, but of course, a sick chicken is sometimes treated with an antimicrobial drug. In some other countries, antibiotics are used much more liberally, often as a way of making the chickens grow larger and faster, a growth promoter. Under both of these circumstances, however, the Campylobacter or other bacteria are exposed to drugs which they then become resistant to. Of course, what that means is if we get a Campylobacter infection, the antibiotics that we take to treat it are less likely to be effective.
Are there things that farmers and the food system can do to reduce the load?
There are, and a lot of it, I think, comes down to economics. You know, enhancing biosecurity undoubtedly reduces the likelihood of a flock becoming infected. We can treat meat after the birds have been slaughtered. So in the US, for example, they do a lot of chlorination, but I don't think, I certainly wouldn't advocate that, and I don't think that's the way to go. My personal opinion, again, would be a really good way to go, and an area where I'm actually doing a lot of research is in developing livestock vaccines. So everybody's familiar with the red lion stamp on eggs. Well, that means that the breeder flock has been vaccinated against salmonella. I would advocate the development, and in fact I'm doing this in my research group, of vaccines against Campylobacter, which would interrupt this transmission strain from chickens to people.
Professor Sam Shepherd from Oxford University. That's all from us. I'm Anna Hill. The producer was Sally Challoner. Farming Today is a BBC Audio Bristol production.